Vision compression meets real datasets. The week's loudest argument. DeepSeek's new OCR release is either a turning point for machine sight or another round of Twitter-grade hyperbole. On one side, advocates point to claims that DeepSeek's pipeline compresses image-based text so efficiently that vision tokens could carry up to an order of magnitude more information than text tokens, potentially enabling AI systems to parse far longer documents and video streams within a fixed context budget. On Reddit, the thesis goes further. Combine OCR compression with graphicacy, representing problems in visual 3D form, and you get dual graphicacy, a proposed two-layer scheme, storage via vision tokens plus 3D physics-like representations that allegedly boosts efficiency for live streams by 2.5x and unlocks real-time robotic perception. Others in the thread push back, calling out the breathless tone and pointing to better analyses elsewhere in the same subreddit. Sensible takeaway: the code exists, the compression claims are exciting, and the robotics extrapolations are speculative. If document compression is the door, better training data is the key. Apple-affiliated researchers introduced Pico Banana 400K, a large-scale dataset for instruction-based image editing built from real photographs in open images. It includes 400K edit pairs produced with Nano Banana, plus 3 valuable subsets, 72K multi-turn sequences for planning and reasoning across edits, 56K preference examples for alignment reward modeling, and paired long-short instructions for instruction rewriting and summarization. This is the kind of carefully curated resource that moves the field from demos to reliable benchmarks, particularly in multi-step, instruction-following editing. Hype aside, the through line is clear. Aggressive compression of visual information and richer, real-world editing corpora are converging. If the former really lifts context ceilings and the latter raises task complexity, multimodal systems get both more input and more reasoned output, exactly what long-form document understanding and video analysis have lacked so far. Running big models locally. On local deployment, Blackwell-class cards are pushing people into surprisingly capable configurations. Users with an RTX Pro 6000 96 GHz report strong results from GPT OSS 120B, fitting the unquantized model, some layers already 4-bit, entirely in VRAM with 128K context and 4 to 5 concurrent sequences, hitting roughly 170 tokens sec for chat and thousands of tokens sec in batch via VLM or TensorRT LLM. Others recommend Qwen80B at FP8, GLM 4.5/4.6 air variants, and Llama 3.370B with quantization choices Q4, Q8, and CPU offloading depending on workload. One gotcha: Vulkan multi-GPU with Llama.cpp, particularly mixed iGPU DGPU setups. A user trying to tensor split GPT OSS 120B across an AMD 780M iGPU and Vega 64 ran into default behavior that ignored the iGPU. The fix was to explicitly pick devices with -device Vulkan 0 Vulkan 1 rather than environment variables. Recent changes reportedly make iGPUs default to ignored when a DGPU is present. Model choice matters as much as the runtime. A thread on Gemma 3 notes that an unofficial GPTQ 4-bit 27B checkpoint exists, but community advice leans to Google's official Q8 variants where possible. Also, Llama.cpp doesn't support tensor parallel, making VLLM a better fit for high-throughput multi-GPU production. One practitioner cites running thousands of concurrent requests on clusters spanning RTX 5090 and AMD 7900 XTX, using tensor parallel where available. Finally, there's an ongoing debate over whether GLM 4.5/4.6 degrade under heavier quantization, or whether inference stacks, e.g. VLLM, are the culprit for observed stupefaction. The practical message: test quant settings across backends before drawing conclusions. Performance cliffs can be backend specific. Agents, vibe coding, deliberation. Software development workflows are shifting from line-by-line coding to vibe coding, implementations validated by outcomes rather than code comprehension. A new survey formalizes the area as a constrained Markov decision process between developers, projects, and coding agents, and synthesizes 5 development models: unconstrained automation, iterative conversational collaboration, planning-driven, test-driven, and context-enhanced. Importantly, the authors report unexpected productivity losses in naive setups and argue that success depends less on raw agent capability and more on context engineering, a robust dev environment, and structured human-agent collaboration. That tracks with practitioners struggling to turn long markdown implementation plans into code changes cost-effectively. One workflow complaint: generating detailed 1,000-line change lists with frontier models like GPT-5 High or Claude Sonnet 4.5 is great for planning but expensive for execution. The ask is pragmatic, scalable, budget-friendly systems that can follow those plans across large enterprise repos with strong context handling. One emerging answer is Agentic Context Engineering ACE. A reproduction repo outlines playbooks as structured context with helpful, harmful counters and 3 interacting roles: generator, reflector, curator. It supports offline and online adaptation loops for multi-epoch and test-time continual learning and shows how to drop in a production LLM. Example wiring uses local GPT-OS 20B on specified GPUs. It's not the official code, but it's a concrete scaffold for evolving contexts rather than static prompts. On the reasoning side, Meta's Stepwiser frames judging as stepwise generative evaluation instead of only checking final answers, aligning the judging signal with the model's own multi-step chain of thought. As tasks get longer and trickier, stepwise judges can reduce mode collapse and overconfidence by rewarding correct intermediate reasoning, not just the end result. Local browsing and command line AI. With browser automation heating up, some are hunting for local alternatives to closed-source agents like Atlas, despite being built on Chromium. Suggestions include Browser OS and using Brave's Leo with local models. For defenses, Qwen's guard models are cited to interpose a prompt injection firewall between untrusted pages and the main LLM. Command line UX is also getting the local-first treatment. Pardus CLI mirrors the Gemini CLI but runs entirely on Ollama, no login, local models only, while the NPC project offers an agentic shell that can use Ollama transformers or API models, with a YAML-based NPC data layer for organizing agent teams. It's a simple but powerful pattern. Make agents a native part of the terminal workflow. For ultra-minimal setups, Karpathy's NanoChat D32 is a tiny chat model drop, albeit with a janky manual file placement. It's not turnkey Hugging Face packaging yet, but it's emblematic of a trend. Lighter local models and tooling tailored to fast feedback loops and personal workflows, not only production clouds. Safety debates and AI text detection. A lengthy safety post revisits a familiar but unresolved question. If emergent capabilities appear unpredictably as models scale, and we push toward agentic AI with autonomy, stable goals, and self-improvement, when does capability exceed reliable oversight? The argument emphasizes instrumental convergence. Agents resist shutdown if it impedes objectives, opaque emergence, and the competitive forces that make pauses unlikely. Comments add a practical angle. Deployment costs already gate access to the strongest models. Ordinary users may never touch them, which is a kind of safety valve, intentional or not. On detection, ReaperGuard proposes a statistics-based method using hidden representation patterns inside a surrogate model. By projecting token layer activations onto a PCA-derived activation feature direction, it produces a REPRE score that separates human-written text from LLM-generated text. The authors observe minimal divergence in early tokens and lower layers, but pronounced separation after 20 tokens and in higher layers, reporting strong ID-OOD performance, robustness to paraphrase length sampling changes, and low data requirements compared to fine-tuned classifiers. Detection isn't a panacea. Adversarial paraphrases and future model shifts will keep moving targets, but the internal representation lens is promising. It avoids brittle surface cues and may generalize better across generators. In parallel with policy and access controls, it's a technical layer worth maturing. Vertical models and scientific agents. Specialized models continue to shine. Kumru 2B, an open Turkish LLM trained from scratch on a 500 GB deduplicated corpus for 300B tokens and SFT on 1M examples, claims state-of-the-art Turkish performance on the Cepvel benchmark, even surpassing much larger multilingual models in grammar correction and summarization. The custom tokenizer, 50,176 vocab, reportedly reduces token counts versus other models by 38 to 98%, squeezing more content into the same context window and cutting inference cost. The Instruct variant targets an 8,192 token context, with model card claims about effective context efficiency versus multilingual tokenizers. On the audio side, practitioners show how to bend general multimodal models into stronger ASR plus translation systems. One tutorial fine-tunes Gemma 3N end-to-end to transcribe German and translate to English, noting poor default performance but successful adaptation after task-specific training. It's a reminder that multimodal won't equal good at everything until aligned with targeted data and objectives. For scientific discovery, agentic tool use is proving concrete. SciExplorer, an LLM-driven agent with code execution, plotting tools, and memory, autonomously explores unknown physics systems to propose and test hypotheses, from recovering equations of motion to inferring Hamiltonians, across mechanical, wave, and quantum many-body domains, with minimal domain-specific guidance. This isn't pure scaling, it's orchestration. Leverage expressive language reasoning to pick experiments and loop on results. Systems hacks, audio in browsers, and hardware DIY. A major systems milestone for creative coders. Supersonic runs Super Collider's SC Synth inside a web audio worklet for real-time cross-platform audio synthesis in the browser. The author avoids deprecated script processor node and re-architects around non-real-time mode run in real-time via microbatching, RTNRT, with shared buffer-based OSC, a custom pre-scheduler, and other low-level changes suited to audio worklet constraints. It's an experimental prototype under GPL v3, already running on Raspberry Pi 5, and points towards serious web-native synthesis without X-runs from main thread GUI interference. On the security tooling side, GoRexJava offers a Go port of the RexJava library for parsing and constructing Java serialized object streams, a niche but important capability for security research and exploit development, where understanding Java serialization formats is table stakes. The project emphasizes safety research and penetration testing use cases. A delightful war story revisits FTP's active mode quirk to pull a 2 GB video capture off an untrusted Windows box stranded on an IoT VLAN, stand up Netcat to impersonate an FTP server, coax the client into issuing a port command revealing the listening socket, then connect to that ephemeral port from the trusted network to receive the file. The narrative includes a byte-level reminder of how port encodes IPs and ports, and the coda that Windows now ships OpenSSH, so next time just enable SSHD and SFTP. Finally, home automation that beats vendor lock-in. A Zender Comfair Q350 HRV gets an open-source display and CAN bus integration via ESP32, enabling remote fan control, filter alerts, and sensor readouts, sidestepping a $300 proprietary upgrade. It's a compact example of reclaiming capability with open firmware and standard buses.